Hello everyone. Today we will be giving you the solution for the monthly math challenge for the month of September. Now the question says Jimmy has the following clothing items in his bag: two caps, two shirts, two jackets, two pairs of socks, and four shoes, which basically means two pairs of shoes. A left shoe and a right shoe will make up one pair. Now the question also says that he can dress up in many different ways, and the ways in which he dresses up must follow these three rules. First of all, he can wear at most one of each item, meaning he cannot put on two shirts. He cannot put on a shirt over another shirt. That would be a violation of the rules. So that's the first rule. Secondly, the socks must be worn before the shoes and the shirt before the jackets. This makes a lot of logical sense as well, because when getting dressed up, we do not put on our shoes before the socks. So this naturally makes sense. We also do not put on our jackets before we put on the shirts. So the order in which we dress up matters a lot here. And next, we can also choose not to wear an item as long as it is practical. So Jimmy might choose to not wear a shirt and just wear a jacket, and that would be a practical way to dress up. That would be a practical way. Uh, if I were to give you an example of what an impractical way to dress up would be, if Jimmy decided that he didn't want to wear shirts and he didn't want to wear jackets either, then he would just be walking around shirtless, which is not a practical way to dress up. Another impractical way to dress up would be to wear everything and then not put on his shoes, because no outfit is complete without the shoes. So I hope you all understood the rules very well, because having a proper understanding on what the rules are is very important for us moving forward. Now that we have understood the rules, the question is asking us to find the different ways in which Jimmy can dress up with these different clothing items while also following the rules that were given to us. So the first way in which he can dress up is if he decides to wear everything. So he decides to wear everything. This means that Jimmy decides to put on a cap, a shirt, a jacket, a pair of socks, and a pair of shoes. So to find the different number of ways in which Jimmy can wear everything, first of all, we have to find the combination. Or we can also say that we can find the different outfits that Jimmy can wear. And okay, so in this scenario where Jimmy is wearing everything, what does he need to make his outfit? He needs to put on a cap, he needs to put on a shirt, he needs to put on a jacket, a pair of socks, and a pair of shoes. But it's not that simple. Out of two caps, he has to select one, so two caps, and then he has two options for shirts, also two options for jackets. He has to pick a pair of socks from two pair of socks, and then a pair of shoes from two options. So 2 times 2 times 2 times 2, which is 2 raised to the power 5, will be the total number of outfits that he can wear, or the different combinations. And this will be equal to 16, I believe. Oh, sorry, 32. Now, that isn't what the question is asking for. The question is asking for the different number of ways in which he can dress up. This is the total number of outfits that he can wear when he's wearing everything. So we also have to look at the order in which he dresses up. So to look for the order, we have to look at the arrangements. So when dressing up, we have to wear everything in a particular order, right? For example, Jimmy might choose to first put on his left sock and then his left shoe, and then his right sock and then his right shoe, and then his shirt and then his jacket and then his cap. But you might choose to put on your left shoe and then your left sock and then your left shoe and then your cap and then your jacket and then your shirt and your right shoe and your right sock. We all have different orders in which we dress up, and each of these different orders make up different arrangements. So if we were to spend our time listing down every possible order or every possible arrangement, it would take us hours for a single outfit. To find the number of total arrangements for a single outfit would take us a very long time. So what we can do here is we can use the use good ideas to find a very fast way to get the answer. So let's try to imagine that we are Jimmy and then we're getting dressed up. Now, what will Jimmy wear first? He could either wear his left sock or his right sock, or his left shoe or his right shoe, or his cap or his shirt or his jacket. So he has 7 different clothing items that he can wear first. So we'll write 7 here. And if Jimmy decided to put on his left sock here, then he cannot put on his left sock again second. That doesn't make any sense. So for Jimmy, what can Jimmy put on second? Well, he has six options. And then what can Jimmy put on third? He has 5 different clothing options, and then it goes on decreasing. We have 7 times 6 times 5 times 4 times 3 times 2 times 1. You can write this simply by writing this as 7 factorial. Now, if you think those are the total number of arrangements, then you would be wrong, because at the very start of the question, we were given restrictions restrictions in the order in which Jimmy dresses up. The restrictions or the rules said that he must put on his socks before he puts on his shoes, which means he must put on his left sock before he puts on his left shoe. So to remove the scenarios in which he puts on his left shoe before his left sock, we must divide the total number of arrangements. So what are some of the rules? He must put on his left sock before he puts on his left shoe. So we divide by 2 here. And then he also must put on his right sock before he puts on his right shoe. So we divide by 2. Then he also must put on his jacket before he puts on his shirt. So we divide by 2 again. Now, to find the total number of ways he can dress up, we must multiply the combinations with the arrangements. So we get 2 raised to 5 times 7 factorial divided by 2 times 2 times 2 is 8. So 2 here, 2 squared times 7 factorial will give us 20,160 different ways to dress up. So that is the number of ways he can wear his outfit for the first case only. Now we have to look at all the different cases. Okay, so the rules also stated that it was not necessary for him to wear every clothing item. So let's look at a scenario in which he decides to wear everything except his cap. So what are the different combinations that he can do here? First of all, let me write it here. There's no cap. Okay, so he is not wearing a cap in his outfit right now. So let's look at the total number of combinations possible, or the total number of outfits that he can wear when he isn't wearing a cap. Well, he could put on a shirt. He has 2 different options for that: a jacket, a pair of socks, and a pair of shoes. Those are the total number of combinations, which is 2 raised to 4, which I believe is 16. Now, you also need to look at the different order or the different combination permutations possible, or the different arrangements possible. So to look at the different arrangements possible, he can wear how many clothing items? Well, since we are not including the cap, he can wear 6 different clothing items, which will give us 6 factorial. But we also know that he must put on his left sock before he puts on his left shoe. He must put on his right sock before he puts on his right shoe, and then his shirt before his jacket. So that would be the total number of arrangements. And to find the total number of ways in which he can dress up when he's not wearing a cap, ways to dress up would be 16 times 6 factorial divided by 2 times 2 times 2. This will be 8. 2 times 6 factorial will be equal to 1440 ways. Okay, that's just another case. We have let's think of another way that Jimmy can dress up in a practical manner, and that would be if he decided to put on a shirt but leave out his jacket. So doesn't wear a jacket. So when Jimmy decides to wear a shirt and not put on a jacket, total number of combinations possible would be equal to, well, he can pick one cap out of two, he can wear a shirt, he can wear a pair of socks and a pair of shoes. And then let's look at the total number of arrangements possible. So to look at the total number of arrangements possible, let's see how many clothing items he can wear. That would be 6 clothing items, am I right? Because he's leaving out his jacket. And now he must put on his left sock before he puts on his left shoe. He must put on his right sock before he puts on his right shoe. But since he's not wearing a jacket, uh, we do not have to account for the scenarios in which he puts on his jacket before he puts on his shirt, because in these scenarios he's not wearing a jacket at all. So we can just ignore that rule where he has to put on a shirt before he puts on a jacket, because in this case he's not wearing a jacket at all. So this is the total number of arrangements. Now total number of ways. Total ways to wear this outfit would be 16 times 6 factorial divided by 2 times 2. 2 times 2 would be 4. So here 4 times 6 factorial will give us 2880 ways. Okay, so let's also look at the cases in which Jimmy decides to not wear a shirt but only put on a jacket. So that would be the same method as before. So Jimmy decides to not put on a shirt, doesn't put on a shirt. So in this case, what the total number of combinations would be okay. So he can put on a cap. He has 2 caps to pick from. He can put on a shirt. He can put on a jacket. Sorry, not a shirt, a jacket, a cap, a pair of socks, and a pair of shoes. Now let's look at the different arrangements, orders in which he can wear the outfit. So let's look at the different clothing items that is available to Jimmy. He has a left sock, a right sock, a left shoe, a right shoe, a shirt, not a shirt, sorry, a jacket, and a cap. So those are 6 clothing items, which means you'll have to do 6 factorial divided by. Now let's account for the restrictions. He must put on his left sock before the left shoe and the right sock before the right shoe. But we do not have to account for the scenarios in which he puts on his jacket before his shirt, because he just doesn't put on a shirt in this case. We do not have to account for that here. We do not need to make any adjustments. Now to find the total number of ways, we can just multiply these two. 2 times 2 times 2 is 16, times 6 factorial divided by 2 times 2 is 4. 4 times 6 factorial, so total ways would be 4 times 6 factorial, right, which would be 2880 ways. 1880 ways. Okay, so that would be your 4th case. Now you also have another case, another way that Jimmy can dress up, which is practical, which is he decides to put on everything. He puts on his cap, his shoes, everything except for the socks. So that's another practical way to dress up. Now what we will do here is we will again look for the different combinations or different outfits that he can make when not putting on a shoe. So that would be he can pick one out of 2 caps, out of 2 shirts. He can pick one out of 2 jackets, and then one out of 2 pairs of shoes. Now we have to also look at the different arrangements or the different orders in which he can put on the outfit. While looking for the arrangements, let's look at the different clothing options available to him. He can put on his left shoe, his right shoe, his shirt, jacket, and cap. So you have 5 clothing items. So this will give us 5 factorial. Now, since he's not wearing any socks, we do not have to eliminate the case scenarios or arrangements in which he puts on his shoes before his socks because he's not wearing any socks here. So what we do have to account for is the different arrangements in which he puts on his jacket before he puts on his shirt. So we only have to divide by 2 here. Combinations, sorry, the total ways. Total ways to dress up. He's not wearing socks would be 2 times 2 to 2, which is 2 raised to 4 times 5 factorial divided by 2 with 2 raised to 3, which is 8. 8 times 5 factorial will give you 960. So there are 960 different ways to dress up when Jimmy is not wearing socks. Now let's look at another practical way to dress up for Jimmy, which would be wearing no jacket and no cap. So not wearing jacket and not wearing cap. So the total number of combinations available here would be he can pick out of 2 caps, 2 shirts. Sorry, he can pick out of 2 shirts, 2 pairs of socks, and 2 shoes. That will be the total number of combinations. Now let's look at the different arrangements possible. How many clothing items are available to us? Well, firstly we had 7, but no jacket, so 6, and then not wearing a cap, so 5. So now there are 5 clothing items available to us. We must account for the arrangements in which he puts on his left shoe before he puts on his left sock, and then his right shoe before his right sock. So by dividing by 4 we are eliminating those arrangements, and now the total number of ways to dress up for Jimmy to dress up when not wearing a jacket and not wearing a cap would be 2 times 2 times 2, which will be 8, times 5 factorial divided by 2 times 2 is 4, so we get 2 times 5 factorial, which is 240. So 240 different ways for Jimmy to get dressed up when he is not wearing a jacket and not wearing a cap. Next, we have another scenario or another way, another outfit which Jimmy can wear, which is practical, which would be no jacket and no socks. So let's do this together. Let's look at the different number of combinations or different number of outfits possible for him, which would be he can pick a cap, a shirt, not a jacket, not a pair of socks, and a pair of shoes. Next, we have to look at the order in which he wears these or the different arrangements. Now, to look at the different arrangements, let's look at the clothing items that he has. So he has no jackets and no socks, so he has 4 clothing items available to him. That would be 4 factorial divided by. Now, let's look at the rules. Okay, so the rules say that he cannot wear a jacket before he puts on his shirt, but he's not wearing a jacket, so we do not have to account for those restrictions. Next, the rules also say that he cannot put on his shoes before he puts on his socks, but he's not wearing any socks, so we do not have to divide again. So that's it. Now we just have to multiply the total number of combinations in the arrangements to get the total number of ways in which Jimmy can dress up when he's not wearing a jacket and not wearing any socks. It would be 2 times 2 times 2 times 4 factorial, which is 192 different outfits. Okay, 192 different outfits or 192 different ways he can get dressed up. Next, let's look at another scenario or another practical way for Jimmy to dress up, which would be without a shirt and without a cap. So let's look at the total number of combinations. So he can pick from 2 caps, not shirts. He can pick a jacket, sorry, no shirt and no cap. So he can pick a jacket, a pair of socks, and a pair of shoes. Next, let's look at the arrangements. So the order in which he dresses up will be the arrangements. Let's look at the number of clothing items he has. He has a left sock, a left shoe, a right sock, a right shoe, and then a jacket. So he can wear 5 different clothing items, which will make 5 factorial divided by, now he is not wearing any shirt, so does not have to look at the rule in which he has to wear a shirt before a jacket, but he is wearing socks. So his left sock comes before his left shoe, then his right sock comes before his right shoe. So we have to divide by 4 here to eliminate the arrangements in which he puts on his shoes and socks in the wrong order. So the total ways in which he can wear the outfit while not wearing any caps or a shirt would be 2 times 2 times 2, which is 8, multiplied to 5 factorial times 4. So this will give us 2 times 5 factorial, which option case number 8, which is 240. 240 different ways to dress up. Now let's try
Charge your phone.
in which let's try and think of another practical way for Jimmy to dress up, which is an outfit in which he's not wearing a cap, so no cap, and he's not wearing any socks, so no socks. So okay, this is the 9th case. Let's look at the different combinations we have. So he can put on a shirt, a jacket, no socks, and a pair of shoes. That will give us 8 different combinations or 8 different outfits that he can wear. Next, we also have to take a look at the different arrangements. We have to take a look at the arrangements or orders in which he dresses up, which will be okay. So how many clothing options does he have? He has 4 different clothing options or clothing items available to him because he cannot wear socks and caps. And okay, so since he's not wearing any socks, we can totally ignore the rule that uh, puts a restriction on the order in which he puts on his socks, but we do have to account for the rule which puts on restriction in the way he wears his shirts and his jackets. So to account for that restriction, we divide by 2 here. So the total number of ways to get to dress up when not wearing caps and not wearing socks would be 2 times 2 times 2, which is 8 times 4 factorial divided by 2. So 4 times 4 factorial. 4 times 4 factorial, which will be 96 different ways. Okay, so let's look at another scenario in which Jimmy can dress up in a practical way. That would be with no shirt and no socks. So the total number of combinations possible here would be he can wear a cap, a jacket, and a pair of shoes. So that will be the total number of combinations, which is equals to 8. Now let's look at the total number of permutations or the total number of arrangements possible. So that would be equal to, so let's look at the total number of clothing options that he has or the clothing items that he can wear. So he has 4 clothing items, 4 factorial. But he's not wearing a shirt and no socks, so we do not have to divide by anything because the restrictions do not apply here. The total ways to dress up when not wearing a shirt and not wearing any socks would be equal to 8 times 4 factorial. 8 times 4 factorial, which is 192. 192 ways to dress up when not wearing shirt and socks. Next, let's look at another way that he can dress up, which will be our 11th case, and that would be not wearing a jacket, not wearing a cap, and not wearing socks. So let's look at the total number of combinations. The total number of clothing items that Jimmy has available to him is very limited in this case. So he can put on he cannot put on a cap. He can put on a shirt though. So two. He cannot put on socks, but he can put on a pair of shoes. Next, let's look at the total number of permutations possible here. How many clothing items are available to him? He can put on a shirt, a right shoe, and a left shoe. So he has three clothing options or clothing items available to him. And do we need to divide? No, because the restrictions do not apply here. So total ways to dress up when he's not wearing any of these would be 3 factorial times 2 squared. 4 times 6 is 24. 24 ways to dress up. Okay, now let's look at another case in which Jimmy can dress up in a practical manner, and that would be if he didn't wear a shirt. So he puts on a jacket. He doesn't wear a cap. Cap is entirely optional, and he does not put on socks. Now let's look at the total number of combinations of the different outfits that he can make with these restrictions. Can he put on a cap? No. Can he put on a shirt? No. Can he put on a jacket? Yes. Can he put on socks? No. Can he put on shoes? Yes. So 2 times 2. And then let's look at the total number of permutations possible, which will be equals to 3 factorial again, because similar to case number 11, he will only have 3 clothing items available to him. Only 3 clothing items. So the total ways to dress up will be 3 factorial times 2, so 6 times 4, which is 24 ways. Now let's come together and try to think of another practical way for Jimmy to dress up. If you spend a long time thinking about it, you'll realize that we have run out of practical ways to dress up. We have went through them all, so what's left? We just have to add everything up. From case number 1 all the way to case number 12, we have to add up all of the solutions. So let's do that. Total number of ways he can dress up. Ways to dress up would be equals to, in the first case we got 20,160, and I'm just going to add them all. 1 0 plus. Okay, so we have added the solutions of all the cases from 1 through 12, and when we plug all of these values into the calculator, we get 29,328 different ways for Jimmy to wear the clothing items that are available to him. So thank you very much for listening, and I hope to see you all next month.